Okay, let's talk about the IB Math internal assessment. It is a huge part of your final grade, and honestly, the most critical step is the very first one, choosing your topic. You get this right, and you are on a path to success. You get it wrong, well, you could be in for a rough time. This whole explainer is designed to make sure that doesn't happen.
So, if you're like most students, you might be staring at a blank document right now, feeling that mix of confusion and, yeah, maybe a little bit of panic. The pressure to find something that's interesting, original, and mathematically solid, it can feel totally overwhelming. Trust me, you are not alone in feeling this way.
And look, this isn't just a feeling, the stakes are genuinely high. As one analysis of hundreds of IAs points out, a poor topic choice means you could be losing points before you've even written a single equation. So making a smart strategic choice right at the beginning, that is your single biggest advantage.
So here's our game plan. We're going to cover the single most common mistake, and then we'll break down 3 key pitfalls to avoid. One about the math, one about the real world, and one about the idea itself. Then we'll wrap it all up with a success checklist that'll take you from that blank page to a brilliant idea.
All right, so what is this one huge mistake we're talking about? It's not a calculation error, it's not a formatting issue, it's the topic selection itself. Almost every major problem that costs students points, from math that's way too simple or way too complex to a lack of personal engagement, it all traces right back to that initial choice.
Let's dive into the first big pitfall, the math. This is where students either aim way too high or way too low, and it has a direct impact on their grade. It's all about finding that sweet spot between being complex enough, having a clear model, and staying connected to what you've actually learned in class. Just look at the difference here. On the left, you've got a topic that sounds incredibly impressive, right? A stochastic SIR model. The problem is, if you tackle that, you're going to spend your entire paper just explaining the basics, not actually showing off your own skills. The much smarter path is on the right. Take something you know really well from your course, like calculus, and just apply it to a new, interesting problem. So specifically, here are the traps you've got to avoid. First, picking a topic that needs math you haven't even been taught yet. Second, choosing something so abstract that there's no clear model. No formulas or variables you can actually work with. And third, wandering so far from the syllabus that your work doesn't show you've mastered the course concepts. And why does this matter? Because these mistakes cost you points. Simple as that. Criterion E, use of mathematics, is all about using math that is, and I quote, commensurate with the level of the course. It's not about using the most complicated math on the planet, it's about using the right math, correctly and with real understanding. All right, let's move on to our second pitfall, which is all about how your IA connects to reality. A great math IA isn't just a bunch of equations on a page. It uses math to explore a real, genuine question. And to do that, you need one absolutely crucial thing: data. You always hear you need enough data, but what does that actually mean? Well, for any kind of meaningful statistical analysis, you should be aiming for a data set with at least 60 to 100 data points. Any less than that, and your conclusions might not even be statistically significant. This number gives you a concrete target to aim for. So where on earth do you find all this data? The good news is you don't have to go collect it all yourself. There are incredible free resources online. The World Bank has tons of global economic statistics, NOAA has this amazing treasure trove of environmental and climate data, and if you're a sports fan, Wolfram Alpha is just fantastic for super detailed stats.
And again, this isn't just about making a cool project. A topic without good data or a clear real-world link directly hurts your score on 2 other criteria. It's really hard to show personal engagement, which is Criterion C, if your project feels totally disconnected from reality. And it's pretty much impossible to do a meaningful reflection, Criterion D, if you don't really have any findings to reflect on.
Okay, that brings us to our third and final major pitfall, and this one is all about the idea itself. It's about originality and finding your own unique perspective. So many students fall into the trap of picking a topic that's been done 1,000 times before, which makes it incredibly hard to stand out from the crowd. Let's talk about the greatest hits of IA topics. You know them: the Monty Hall problem, the birthday paradox, finding the Fibonacci sequence in pine cones. Look, these are fascinating ideas, but your examiner has probably read dozens of IAs about them. It's not that they're banned, but if you pick one, the pressure is really on you to bring something new to the table. But wait, this doesn't mean you have to avoid them completely. The solution isn't to find a totally unheard of topic, but to find a unique mathematical angle that turns a simple explanation into a real investigation. It's all about asking a different kind of question.
Let me give you a perfect example of a tool that can do this for you: expected value. It's basically a way to calculate the average outcome of something if it happens over and over again. You weigh every possible result by its probability. It's the secret sauce behind how casinos and lotteries actually work.
So, think about it. Instead of writing another IA that just calculates the tiny probability of winning the lottery, what if you used expected value? You could analyze the ticket price, all the different prize amounts, and the odds to figure out if, on average, a ticket is actually worth buying. See how it shifts the question from "can I win" to "is this a good financial decision?" Now that's an investigation.
And that is exactly what the IB is looking for when they talk about personal engagement. When you take a common idea but you apply a sophisticated mathematical lens to it, you're showing creativity, initiative, and a real curiosity. It proves you're not just repeating something you read online, you're using math as a tool to see the world in a new way. Okay, we have waded through all the pitfalls. Let's pull this all together into a super simple, actionable checklist. As you're brainstorming your ideas, run every single one of them through these 7 checks to see if it's got what it takes.
Okay, here we go. 1. Does it match your skill level? Be honest. Is it challenging but not impossible? 2. Is there a clear mathematical model you can apply? 3. Can you find enough quality data? Remember, at least 60 points. 4. Does it connect clearly to your IB math syllabus? 5. Does it have a practical, real-world application? 6. Is there enough depth here to actually explore, or are you going to run out of things to say after 2 pages? And finally, number 7, have you found an original approach or a unique angle?
So, I'm going to leave you with one final thought. Don't just ask, "what's a good topic?" Instead, ask yourself this: what real-world problem, big or small, will my math solve? That's the mindset that turns a school assignment into a fantastic piece of mathematical exploration. Good luck!
Thank you so much for watching! And for more helpful videos, math and science videos, don't forget to like this video and subscribe to our channel. See you soon!